Before we get started, just a reminder that you can find all of my available rental properties on my website at marcguzman.com. If you own investment property, click on the Owner Services section to see our complete list of services. This episode and wine tasting is sponsored by Lenny Clark with Prime Lending. Lenny Clark is a loan officer specializing in residential home lending. He communicates with you every step of the way, and his honesty sets him apart from the rest. He's able to think outside of the box due to his experience and is able to tailor a loan program to fit your needs. If you can't qualify just yet, not a problem. He will let you know what you need to do in order to be ready. Lanny is also backed by Prime Lending, which is one of the biggest and fastest growing lending banks in the nation. They have simplified the home lending process down to 5 steps. And FYI, step number 5 is to relax and enjoy your new home. So contact Lenny Clark today at 510-964-0620. Crime dramas are a staple of American television culture. For decades, shows like CSI, How to Get Away with Murder, Magnum PI, and many others have captured our imagination and given us a peek at the world of criminal science. But like with anything you see on TV, what happens in these shows is not always the same as what happens in real life, no matter how accurate the show may seem. Our guest today is Jennifer Mihalovich, a DNA technical leader that has over 35 years of experience in forensic science. Today, we are going to have her shed some light on the real world of forensic crime solving. Okay, perfect. Jennifer, thank you for being on the show here.
Well, thank you, Marc. It's nice to be here.
I'm excited for this. Sam, once we had you booked, I was really excited to get into this show here because I think everyone has seen some kind of crime drama show. And there's a lot of course, we know it's television, but a lot of that has also gone out into the public perception of how things really work.
Yes.
And there's a lot of, they're not really facts, but just misconceptions, really. So I'm glad to have you here on the show and want to dive into a lot of this.
Okay.
So first off, let's talk a little bit about your backstory. How did you become a criminalist?
So I worked at the University of Montana in the crime. Excuse me, I'm going to screw this all up. I worked in the University of Montana chemistry department, and the professor there was very interested in forensic science. And basically, he was into firearms analysis. And he kept telling me, Jennifer, go check out the Montana State Crime Lab because they have work study money there. And that's one of the ways I was putting myself through school was work study money. So just by happenstance, my husband and I were walking by the laboratory. We popped in. The lab director there said, fill out an application for the job, and I did. And the serologist at the time called me and kept leaving messages on our answering machine to come in and see him. And I did, and I got the work study position job there. And so I worked 19 to 20 hours a week in a crime laboratory while I was an undergraduate at the University of Montana. And while I was there, I decided that I would go to graduate school. And he helped me get into the University of California at Berkeley, where I got my master's in public health, and the emphasis is in forensic science.
So you didn't grow up originally in California, but what made you decide to stay here in California?
Well, there's no snow, at least where we live. I don't have to plug my car in. The Bay Area actually fit both my lifestyle and my husband's lifestyle. We like the energy. We like the ability to do things that we want to do without having to drive very far. We like the people that live here. We like the diversity. We like how liberal people typically are.
So let's get into what was the type of education that you had to go through to become a criminalist?
So my undergraduate degree is in microbiology, and I have a minor in chemistry. So basically the hard sciences, chemistry, physics, math, biology, biochemistry, molecular biology. And to do what I do now at the law enforcement agency that I work at right now as the DNA technical leader, I also have to have a master's degree. And with that degree, I also have to have genetics, statistics, molecular biology in order to be in that position.
Wow. That's a lot of education, a lot of knowledge right there.
It's a lot of science.
Yeah.
My favorite classes were physics, though.
So, so you got the education, and so you're a DNA technical leader, and
Yes.
that's what you've been doing now for over 35 years.
DNA technical leader for almost 20 years, 20 years in a couple of weeks. Prior to that, I was a criminalist that just did cases in a private laboratory.
Okay. Now, briefly, we were talking about before we started recording the difference between a criminalist and criminology. So,
Yes.
if you can break down for the listeners what the difference is.
A criminalist is a person who is a scientist that uses scientific methods to study the physical evidence left behind at crime scenes. A criminologist studies the psychology of the criminal. So if you equate it to a TV show, it'd be like Criminal Minds versus NCIS.
Hmm. Okay. Yeah, that's the first thing that popped into my mind, criminal minds, as soon as you said criminology.
Yes,
Yeah.
absolutely. Kind of a scary show.
Yeah. But it's a TV show.
It is.
So, so what made you get into this type of field? I mean, what was your motivation behind it?
I really didn't know very much about it when I was in undergraduate. In fact, when I looked for graduate schools, one of the schools that popped up was public speaking, because that's what forensics means, is public speaking. In undergraduate, my goal was to become a medical technologist, and I tell this story that as a medical technologist, I would always be afraid that I would do something wrong that would cause somebody's demise, whereas as a criminalist, I don't have to worry about that.
Hmm.
They're already
Yeah.
dead. Sorry, that was a little, a little crass.
So, so what have been some of the enjoyable moments for you, though?
So I thoroughly love my career. It's an excellent career for people to get into that like science and want to do something for the betterment of society. Um, some of the cool things that I've done over the years are research projects that have led me to advance forensic science in the world or in the nation or even in just our own lab. We automated one of the uh, processes that is used in sexual assault evidence exam. That was very exciting. We took a situation where I could do maybe 17 samples in a day, and we automated it. Now we can do 96 samples in a day.
Wow.
So that really sped things up. So I like doing that. I like teaching. I like showing the younger scientists how to examine evidence and see what answers that they can come up with.
So, are you mainly working inside of a lab all day long, or do you go out into the field also?
Mainly in the laboratory. On a very rare occasion do I go out to crime scenes. And in the course of my career, I've probably gone to 5 or 6 crime scenes.
Okay. So not many. So you're
No.
really in the lab then, for the most
Yes.
part.
Yes, I am.
Now, so you're really studying all the evidence that's brought in by people out in the field, and these would be police officers. These would be the actual. I'm drawing a blank right now on the
Evidence collection technicians.
correct. So the evidence collection technicians go out, they collect the evidence, bring it back. Is it? Do you ever run across problems where how it's collected or even tainted evidence?
Um, yes, and that's happened in the when I worked in the private laboratory all the way through to today. In an ideal world, everything would be collected properly and everything would be collected. In situations, that just doesn't happen. I've worked on several old cases where all that was left was the cells on a microscope slide, and we had to work with those cells versus working with the primary evidence.
I imagine that would be very tough to go back and work a very old case or to look at evidence, even if things are stored because things decay over time.
That's right. Those are actually the most fun cases. One of my favorite cases that I love to tell is a homicide investigator called me when I was working in a private laboratory and said, Jennifer, I'm due to retire soon, and when I became a homicide detective, this was my very first case. It's remained unsolved all this time. Is there anything that you can do with it? And this is a case from 1969, and it had been stored in Central Valley, where you have various fluctuations in temperature and humidity over the year. And we were able to actually get DNA typing out of that, and we were able to solve that case. So he started his career with an unsolved case, but ended with it being solved.
Wow.
That was kind of rewarding for him, knowing that.
Yeah, I would imagine as the years go by, technology gets better, and then you can go back to a lot of the evidence in unsolved cases
Absolutely,
and then start to analyze that evidence.
absolutely.
So the one type of testing that everyone hears all the time, especially in the crime shows, is DNA testing.
Yes,
And DNA testing is still relatively new, right?
we started doing DNA analysis on evidence in 1986. Um, with the uses, it's called PCR. It's short for polymerase chain reaction. It's at that time it was very new and novel, but it has expanded to worldwide use using the PCR process. The cases that I used to work on back in the late 80s, early 90s have many of them have gone back and done the more sophisticated methods that we are using today to help locate, or if you will, find the potential perpetrator of the crime.
Has DNA testing today become uh, like an absolute, hey, it's 100%, we know this is it? Or are there still some flaws in DNA testing?
Um, well, as scientists, we use the scientific method, and that is we try to prove a hypothesis false. So I can never say that that blood stain belongs to Mark to the exclusion of all others as a scientist. But what I can do is say we've tried everything that's in our toolbox and we cannot eliminate Mark. And that profile occurs in 1 in 6 octillion members of the world, which is a vastly huge number.
Yeah.
In my opinion, would it be you? Yes, unless you have an evil twin. And, you can't tell the difference between identical twins. The other misconception that a lot of lay people have, and actually even other scientists have, is when you end up with a mixture of biological material, let's say you have 2 blood sources, you might not be able to tell whose sample came from who, and you'll end up with a mixture where a multiple of people can be part of. And one of those types of cases comes off of weapons like guns. It low level degraded mixtures. We can't really do too much with it.
Hmm.
And
I was just,
go ahead.
I was gonna say, so going back to what is it, 1 in
6 octillion.
6 octillion. So I was recently just watching People versus OJ, the Netflix series, and
Yes.
one of the pieces of evidence that the prosecutors brought up was the DNA, right?
Yes.
And they were at the time, I think the case was 96 or
Yes.
yeah,
94,
94,
96.
yeah. And they were saying, "Oh, well, this is still relatively new testing, but the chances that it's his blood is 1 in like 177 billion or something,
Yes.
something like that." And I mean, we all obviously know how that case ended, but that was the one thing that the Netflix series used to create some doubt in Robert Kardashian's mind about, well, did OJ really do this? Because that's a pretty odd. I mean, that's fairly certain that, hey, that's his blood.
Yes. Unless it was a mixture, and maybe they had. That gives you some doubt that it could be potentially something
Well,
else
I,
going
I
on.
kind of have a question on that one.
Okay.
Just with the numbering, when it says there's a 1 in 100 billion chance of a match, how can it be that if there's only 6 billion people on the earth?
It's so the way you phrased your question is a little tricky because it's not a chance. It's how rare or how common that type is. So if are you familiar with ABO typing? For
Correct.
example, I'm an ABO type B. Well, there's only 4 ABO types. There's A, there's B, there's O, and there's AB. Well, more than one person has to have that one of those types. So ABO type O is 40% of the population. ABO type O is A and O are about 40% of the population. ABO type B is about 8% of the population. And ABO AB is about 2. So it's the same way when you're talking about DNA typing. Each of us have a set of genetic markers, a set of markers within our DNA that we share with other people, the same marker, but it's the combination of those markers that lead to that rare number. So uh, you and your dad, Mark, share 50% of your DNA
Hmm.
because you get 50% from your mom and 50% from your dad.
Okay.
You and your son would share 50% for the same reason, but he'd also have some of your dad's and some of your mom's. So it's the combination of those markers, and they change as you have more and more generations going. And you and Sam will have totally different DNA, but you might have one marker that's the same. And not that you got it from, he got it from your dad. No, he got it because of other pairings that were going on. It's kind of complex, but
Yeah, it's very complex. I mean, if you go back and even trace the human evolution, I mean, we're now Homo sapiens, but if you go back and really look at the various species of humans, if you will,
mhm.
I want to say they're in the 20s. Like, there were a lot of them. And the just mixing of all these different species and eventually just coming down to the Homo sapien. I
Yes.
mean, you can trace a lot of this back through the DNA, right?
Yes, you can. Yes, absolutely.
And that's part of the whole, like, what is it, 23andMe, Ancestry.com, where they can even trace your DNA back to the specific roots or the areas or the regions, right?
Yes, exactly right. So, for example, it's not surprising that my DNA through 23andMe shows that I have a strong Eastern European descent, which is logical because I'm German, mainly German, Polish.
Okay. Stuff's very interesting, but it's very complicated. I mean, I want to say when DNA testing and reading the actual DNA entire code or the entire line took like days or weeks to actually read it, and now they can do it within a few minutes, right?
It took, I think, about 12 years to do the first uh, tire sequencing of the
12
human.
years.
It took a very long time, and now you can do it in a matter of hours in some cases. So when we do DNA analysis in the lab, we actually don't sequence the DNA in that fashion. We actually look at genetic markers, and the markers that we look at are called short tandem repeats. And right now we're looking at 23 of those genetic markers. And we can tell if the biological material came from a male or from a female based upon the X or the Y present. And that's very helpful in some cases. Um, and you were right about DNA degrading over time. And in the OJ case, they had both styles of DNA analysis going on. In the beginning, there was RFLP analysis, which required a lot of DNA and it to be relatively intact. And they used that process in the OJ case, and they also used the PCR process in the OJ case. I actually did do some work on the OJ case for the defense, and uh, although I don't remember a lot of the stuff that I did, because that was a long time ago. But the OJ case is very interesting because that really brought the crime laboratory into the focus of people, because people were watching it every day.
Hmm.
And it had its good points and it had its bad points. And the best part about it was it really did bring into the limelight forensic science. And I think of that as a pivotal point for the crime lab starting to get more and more funding to actually do more and more work, which was great.
Now, you worked in a private lab and also now working in the public's, I mean, yeah, the
Public lab.
public's
Hmm.
public office. How's the funding between the two? Is one better than the other?
Oh, no. The private laboratory is fee-based, and so a client would call us up and say, "We would like to hire you to work on this case." And at the time that I left, we were charging $175 an hour, and for every hour I spent working on the case, that's how much we would bill the client. Well, that works really well if you have a lot of clients, but if you don't have a lot of clients, then you don't have the money coming in. And so it goes with the economy. And funny thing is when the economy is bad, the actual crime laboratory work was high. Could never figure
Hmm.
out why that was, but that's what it was.
Maybe more crimes.
Maybe more crimes, people trying to get out of crimes. I don't know. I worked with a lot of different clients. We worked mainly for prosecution agencies across the U.S., a handful of defense agencies. Innocence Project, we did a lot of work for the Innocence Project. And then just a small number of cases from private individuals. Like, for example, you could call up and say, "I have something going on. Can you test this for me?"
Hmm. How many cases do you have going on at any given time?
On average, in the agency that I work for, in the DNA unit that we work in, we do probably between 400 and 600 cases a year. And that's based upon capacity. Could we do more? Absolutely. We need, like every crime laboratory, needs more scientists doing the work, more space to do the work in.
Hmm. Wow, that's still a lot of cases.
It is.
Now, with DNA as it degrades over time, um, does that really depend on the quality of of the original sample, or I mean, how long does it take before you just can't even test DNA
Right.
anymore?
That's a good question. I always tell people if you equate biological material, because that's where your DNA is in the biological material, to a carton of milk. If you tuck your carton of milk into the refrigerator, it'll last for, a fairly long time, but over time it does spoil and go bad. The same is true with biological evidence, the blood stain found at a crime scene, if you stored it in the refrigerator. If you dried down that milk and kept it dry, it would last for quite some time and you can rehydrate it. The best way to store the biological evidence is dry it down and store it frozen, and that'll last even longer. If you start out with a dime size of a blood stain, you can probably do DNA analysis if it's stored dried and frozen for decades. If it's a pinpoint of blood and it's left out in a Louisiana lab because of how hot and humid it gets, it's probably not going to last very long
Hmm.
because it's the humidity that allows it to degrade.
Yeah, I would imagine that's got to be a very, very tough challenge for a lot of people that go back and try cases that they believe their client is innocent,
Hmm.
and they go back to try the evidence and it's just not there anymore.
Yes,
Or it's very tough to test because if you can't get a good sample, you can't really get a good quality test off of it, correct?
right. I've worked on several post conviction cases, and I did bring some information on a couple of them that I would like to share if
Yeah, of
you're
course.
willing. One of my first ones that I ever worked on was Glendale Woodall. He was out of West Virginia, and the original evidence on that case was examined by Fred Zane, a serologist at that laboratory. Fred Zane um, has a very bad reputation, and if people Google Fred Zane, that they'll find that he fabricated evidence and was not a very good scientist, and does not make me very happy as how he portrayed forensic science when he did this work. So we got this work into the laboratory, the evidence into the laboratory, and we looked at it. We were able to eliminate Glendale Woodall as being the source of the biological material on this sexual assault. He was originally sentenced to 335 years for 2 sexual assaults, and he did spend 5 years in prison. He was the first person to be exonerated using DNA, and I was able to testify on that case, and it was kind of exciting.
That is exciting.
So
Yeah.
to be able to use science to go back and look at old evidence, that was really great. And then there's another one that
I would imagine though that would have been very tough for the entire lab to find out that this person was fabricating evidence. I mean, unless all of them were in on it, but
they weren't all in on it, but he was the supervisor at the time, and so there is this kind of he had an ego problem. He wanted to do the best for the prosecution and to get the man, and that's not what science is about. The science is there to look at the evidence and tell its story in that fashion. Uh, yeah, so look up Fred. He's an interesting character.
Fred Zane.
I'm looking it
Zane.
up on Wikipedia right now. And, yeah, I got a bit on his background. We got a bit on his background, the West Virginia work with Glenn Woodall, and then the further investigation, investigation in Texas County that found while working with Bexar County Medical Examiner's Office, Zane engaged in misconduct and fraud that may have resulted in as many as 180 wrongful convictions.
Wow.
Wow. So he died of liver cancer in 2002.
Yeah, and then at that point, I feel like once they discover one case was fabricated or the evidence was fabricated, now they have to go back at all the other prior cases.
Yes.
And then that takes up a lot of resources.
Yes. Absolutely does. But it's worth it.
Oh, of
Because
course, yeah.
you wouldn't want some innocent individual to be sitting in prison, especially considering the bad guy's out potentially doing more bad crimes. So there's both sides of that story. I'd rather have the bad guy in prison, rightly so, than to have some innocent person spending his life there or her life.
So would they have to go back in a case like that? Would they have to go back and retest all the evidence, or just, I guess, investigate how that evidence, how it concluded to a determination that the person was guilty?
The latter part is true. So you'd want to look at all of the cases. And in some cases, the evidence that he may have worked on was moot or meaningless to the nature of the case itself. And it may not even have been brought in at trial. So they may not need to relook at that case. But I'm sure that they looked at many, many cases.
Okay.
There's another case that we looked at out of Canada. Guy Paul Morin, Morin. You can also look him up if you want. He was the next door
What was
neighbor.
the name again?
Guy, Guy, but it's pronounced Guy. Paul Morin. He was a young man that lived next door to a little girl that went missing. And this is out of Canada. And they had prosecuted him and they wanted more work to be done. And they found the remains of the victim. And we got in her underpants and we looked at the stains on the underpants and were able to eliminate Marin as the source of the DNA on the underpants. That case remains unsolved today. But one of the things that came out of that post-conviction case was a significant evaluation of the crime labs in Canada. And there was also one of the things that connected Marin to the crime were fibers. Well, it turns out that it was a contamination of fibers within the laboratory from one case that had been examined previously and the case that Marin was involved in. And so it was a contamination of those fibers that led to some testimony that implicated Marin in that case. And so that was a huge undertaking from the Crown to go back and look at that case.
Wow.
And look at forensic science on that.
Now, when people mention fibers, that refers to like clothing.
Clothing, yeah, right. So like blue jean fibers everywhere, right? My black sweater fiber is probably everywhere. Silk fibers, natural fibers with a special dye, might not be so much everywhere. The carpet fibers from cars, there's a specific style that they put into cars, and sometimes you can tell which fibers they are and which aren't. The I think it was the Green River Killer out in Atlanta, where they associated the fibers from the carpet the boys were found in back to the apartment of the suspect who was later convicted of those crimes.
Oh, the carpet fiber.
Mm-hmm. Yeah. So there's but besides DNA and biological material, there's lots of evidence that can connect people together. Hairs are okay, but hairs can be found everywhere. I'm sure when I leave here today, you'll have a pile of my hairs hanging around. And I'll probably have some of yours on me too. Um, and the only way that you can uniquely tie the hairs back to an individual is through the DNA work. To do microscopic examination on the hairs, you can kind of classify. I mean, the difference between your hair and my hair would be very obvious. Yours is black, mine is dyed. Yours is short, mine is long. But our arm hairs might be the same. You know, maybe I might have a gray one and you might have a gray one. So it's kind of hard to tell the difference on those unless you went into the DNA.
Okay, but you can extract the DNA from hair.
From the hair roots, if you have a hair root, you can do the type of DNA work that I do. And then from the shaft portion, you can use mitochondrial DNA. And that's a little bit different. Mitochondrial DNA you get from your mom only. And so your mitochondrial DNA and your mom's are the same, as would be your brothers and your sisters. But your children will not have your mom's mitochondrial DNA. They'll have your wife's or their mother. Whereas your sister's son will have your mom's mitochondrial DNA. And so that's how they found Eve, is by use of the mitochondrial DNA, going back years. And then the other chromosome that we look at are the Y chromosome. So all males have, well, almost all males have Y chromosomes, unless there's a genetic abnormality. But with the Y chromosome, you will pass that on to your son. So you and your brother will have the same Y chromosome, and you'll pass that on to the boys in the family. That's how they were able to trace back the individual as being biologically related to Jefferson from the slave era.
Okay.
That's how they were able to do that, was through the Ys.
Wow. Wow. So what kind of device are you using to analyze the DNA within a strand of hair?
Okay, so the DNA, once you get it, is the same as any other DNA. DNA from a blood stain is the same as the DNA from a hair, is the same as the DNA from a semen stain.
So what are you doing then to extract the DNA from that sample?
Okay, so one of the questions that you had asked was how a case is processed. So if, I can walk through how that goes,
Yeah.
and we'll just use, for ease, let's just use a nice juicy blood stain.
Okay.
So let's say somebody is stabbed and the perpetrator is caught, or the supposed perpetrator is caught, and on his shirt is a nice big old blood stain. And we want to know, is that blood stain from the victim or from somebody else? So we'll take a small cutting of that blood stain, usually about 1/8 of an inch square. So it's really small. And we'll put it into a small plastic tube. It's called a microfuge tube. And we'll add some chemicals to it. The chemicals contain a detergent, somewhat similar to the detergent you would use in your dishes. I mean, you can use that, but it's a little bit more sophisticated. And then it also has an enzyme that's called proteinase K. Proteinase K chews up proteins. So if you were to put it, if you'd get it splashed on your skin, it would actually start chewing up your skin because you're made out of protein. So what that does is it breaks open the cells walls, and leaves us the ability to extract the DNA. And the extraction of the DNA is by removing all of the protein and the extra cell material away from it. So now we have the extracted DNA, and we need to do what's called amplification, or photocopying the specific regions of DNA over and over again. And that's a very simple process, and I just wish I would have thought of it. Kerry Mullis thought of it. At that time, he was working at CETUS, and he won the Nobel Prize for Chemistry for coming up with this process. And basically what it does is if you equate DNA to a ladder, it's double-stranded. So you have the sides being the sides of the ladder and the base pairs being the rungs between the two rails of the ladder. So what PCR does, or amplification does, is it It's like you took a chainsaw and you ran it straight up the middle of that ladder and it split it open. And then along comes an enzyme called Taq polymerase. And wherever it sees an A, it'll put down a T. And wherever it sees a G, it'll put down a C. Let me back up a little bit. DNA is composed of 4 bases: A, T, G, and C. A will always pair with T, and G will always pair with C. So basically, all this is a heating and cooling device. You heat it up, the DNA separates, the Taq comes in, it does its job. You're back to having, from one ladder, you now have 2. From 2 ladders, you now have 4. 4 to 8, 8 to 16, 16 to 32, 32 to 64, and so on. We do that so that we have enough DNA to then detect. So the part of the amplification process has a starting block, and that starting block is tagged with a fluorescent dye that glows when it's hit with a laser. So what we do is we take the amplified DNA and we apply an electric current to it. And DNA is a negatively charged molecule. And so negative will attract a positive, just like your car batteries. It's basically kind of the same thing. You have a positive and a negative pole. And the DNA, based upon its size, how short or how long its fragments are, will then go past a laser detector, which will then, the fluorescent molecule will fluoresce, and a CCD camera will capture that fluorescence. And from there, we can determine how long or short the DNA fragment is. And we compare that to a DNA ladder or a DNA decoder ring, and that will tell us what types they are. It's very involved. It's probably, I described it in a much more simplified way than what it really is. So there's a lot going on to it. The instrument that we use is called a capillary electrophoresis device. That costs about $95,000. And currently, you can run up to 24 samples at one time. It takes about 45 minutes a sample. There are new devices on the horizon. There's a rapid DNA detection device that can run 4 samples from start to finish in about 90 minutes. But that right now we can only use on reference samples. So it would be a reference cheek swab from you. We can't use it on evidence yet.
Wow, that's that entire process kind of went over my head.
That's okay.
I got I know I got you cut the ladder with a chainsaw down in the middle and then you attach a car battery to it. Wow. But that's very impressive though because every single step it's all science and
Yes.
it's amazing like the smart people that have just come together to develop and continue developing the field and the testing methods and it's just incredible.
Yes. So the process that I described to you, it's used in crime laboratories, but it's also used in lots of other places in the medical field, in identification of the MIAs, missing in action individuals. It's used in animal genetics. They want to know the pedigree of the parrot. Um, it's used in plant genetics. It's used all over.
Now, have you been an expert witness before?
Yes, I've testified probably 80 to 90 times.
Okay. So I would imagine one of the most difficult things about being an expert witness, other than the other side trying to discredit you and your work, is trying to simply get the scientific terms across to the jurors.
Yes.
Because, like everything you said, I kind of have an idea, but I'm not going to know every single step of those process and really how it works, right?
Right.
How does the chemical really break down the cell walls and I'm not gonna understand. You can explain it to me, and you're gonna dumb it down as much as possible. But I mean, how do you really explain it to people, especially to jurors that they don't know?
So basically, my explanation to you was a lot more detailed than what I would do in court. typically when I go to court, I find out the education level of the jury because I don't want to talk down and I don't want to overwhelm. And so a lot of the stuff that I told you, the extraction of the DNA, I put in a detergent and I put in a chemical that breaks open the cell. From there, we have the DNA. And I talk about the ladder and going up the middle of the ladder and the copying, just like a Xerox machine copying. And then we have enough to work with and we can um, run it through the instrument and we can get the DNA types results from there. So usually it's not too detailed. I gave you a lot more detail than what I would typically give. When I first started testifying about DNA and nobody really knew about it in the court system, I would spend hours and hours and hours testifying on the process and who's doing it and how many papers have been written. Now, because DNA is everywhere in terms of in the lay person's arena, it's on TV, it's on the news, they're reading about it in their murder mysteries, everywhere.
In fact, in TV shows, you can look at DNA and just say, I know it's that person's DNA.
Yeah, it's not quite that fast. We don't really go into that much detail anymore. In fact, if we testify for more than about 2 or 3 hours, that's a long time testifying.
Mhm.
So it's just become more accepted, more understood.
Do you have any pet peeves when it comes to the public perception of DNA and DNA testing?
Yes. My biggest pet peeve, you've heard me use the term biological material. Um, so when people say, oh, I got DNA on me, well, I hope DNA isn't flying through the air free. So usually it's the biological material. I got somebody's spit on me. It's within the spit, the cells within the spit that has the DNA. So that's one of my pet peeves. But I've grown used to hearing, I got DNA on me.
So
Excuse me.
let's talk a little bit about cold cases. At what point do prosecutors or detectives determine a case is cold?
Well, that's a good question for the investigators to answer. In a lot of times, they just have no leads. There's just nothing to go on. Drive-by shootings, for example, you don't have anything that can link it back to a person. Uh, in this era that we're living in now, you see a lot more video, so you're seeing a lot more of the cars being identified. But back in the day when there wasn't video, you really couldn't do that. The One of the cases that I talked with Kim about was a cold case, and I have a feeling that that's the one that you want to ask about. It's a case that truly was cold. It started happening in, let me get my, it's called the Gypsy Hill Killer, and it started in essentially 1976. There were the two cases that I worked on when I worked on it in 1996. So that was already 20 years old by the time I got it.
Wow.
So it was considered cold then. And that's when we started doing some DNA work on it. And we still didn't get anything on that. And it was the cases that I worked on were two young girls that had been murdered, two teenagers. And that case would remain unsolved today, except for the perpetrator of that case ran into some bad luck. So he was arrested, tried, and convicted for crimes in Nevada back in the day. And he didn't like being in prison, so he decided that he would escape. Well, when he escaped, he went to Oregon and did a rape and an attempted homicide. Well, he was caught. And he was tried at that time. But because he was an escapee from Nevada, he was sent back to Nevada to finish out his sentence. Well, currently the Nevada law, and it is being changed, is you don't give a DNA sample, there's that terrible term again, reference sample to get put into the DNA database until after you're released. Well, if you die in prison, you would never give a sample. If you're never released from prison, you would never give a sample. Well, this individual had finally finished his term in Nevada and was transferred over to Oregon. Well, in Oregon, that's when they did his sample, and that was in 2013. So when they did that sample in 2013, it was put into the DNA database, and that's when it hit the San Mateo cases, and he was charged for those two cases in 2014.
Wow. And that
So
was from
that
76?
was from 1976.
Wow.
And they suspect him of being responsible for at least, I think, two other homicides in the Bay Area at that time.
Wow.
Um,
But if he had given a sample earlier, or if they had taken a sample, they would have identified him way
Earlier,
earlier.
yes, but not in 96. They probably wouldn't have identified him until maybe 2003 or so. That's when the genetic markers came along, 2000, 2003, that we use now for the DNA database that's easily searched.
Hmm.
So I had to go and testify on that case about the work that I did in 1996. And looking back at all of my old notes and stuff, I'm like, wow, we've come so far.
Yeah. Yeah, I bet. I mean, and now just going forward, I mean, what are some of the advances that you're seeing going forward in DNA testing?
There's a system that's available now, although it's kind of expensive to use in the crime lab. It's called next gen sequencing or massively parallel sequencing. And with that, you can look at thousands of markers. And in fact, you can do what's called phenotyping. You can tell the difference between my blue eyes and your brown eyes. And they may be able to do that. They may be able to do hair color. They may be able to do skin pigmentation density to try and see uh, what Caucasian to African American range, plus all of the genetic markers that we're doing now. It's that process right now is very laborious. It takes a long time to do a sample, and it is kind of expensive. But I see that coming down the pipe. In fact, I expected it to be here already.
Well, I'm sure if you look at the costs of DNA testing when it first started to come out, it was very expensive compared to the cost of today.
Well, one would think, but you're actually wrong. It keeps getting
Really?
more and more and more expensive. It seems like, anyways. So right now, it costs about for just one small portion of the testing, chemicals is $21 to $25 a sample, and that doesn't include all of the other reagents leading up to that, plus the time. And each case has a minimum of the smallest case that I can see working would have probably 5 to 6 samples. Let's talk about the blood stain on the shirt. So it would be the blood stain. So that would be one sample. You'd have to have a control sample for that. You'd have to have what's called a kit standard and a PCR blank for that. And then you'd have to have reference samples. So if you have the perpetrator, you'd have the perpetrator's reference sample, the victim's reference sample, and a reagent blank for that. So that would be 7 samples at a minimum right there. And that's just for a one stain case. And we rarely work on cases that have only one stain.
So it'd be like 25 times 7.
7. Just in that
Just that sample alone.
right, for that particular set of reagents.
Wow.
So
So if there's a crime scene where they're taking 10
hundreds of
or
samples
hundreds of samples, you're essentially looking at 7 times 100.
times 21.
Wow.
Yeah.
Okay. So yeah, it can get very expensive very quickly
Yeah.
just based on the number of samples and uh, the number of samples collected, and then what you need to control it to make sure it's being done correctly, right?
Right. That's what the blanks that I talked about, that's what we use to help control for the process that we do in the laboratory. So that if we have contamination in the laboratory, we can find it and deal with it. And the kit standard, we use that so that we know that the reagents are working properly. Because if it gave us the wrong answer in the kit standard, we'd go, something's not right here, and we'd have to troubleshoot it and figure out what's going on.
Hmm. So let's talk about TV versus reality because I'm sure most people have seen Law and Order. That's a popular one. Chicago PD, CSI. See, how many versions of CSI
Oh,
are there?
a
There's
billion.
a billion, right? Just as many as there are DNA sequence markers, right?
Yep.
So, in your opinion, what's the most realistic one? Is there one that's more realistic?
One of the most realistic ones is Quincy, but that's very, very dated now. And in fact, one of the consultants to that show was a criminalist, and he made sure that a lot of the stuff rang true in that show. But that was way before DNA analysis became popular. NCIS is somewhat realistic, although typically one criminalist wouldn't do everything. That Penny, is that her name?
Penny, yeah.
Yeah, one criminalist could not do everything that she does. Some of the instruments that they show on the TV shows, they say is a DNA typing instrument when it's actually a toxicology instrument, or vice versa. Um, so it's interesting to see when they mix up instruments, and yeah, that's pretty funny. So probably NCIS is the most realistic in terms of what you see and some of the things that can happen.
Are your labs constantly like the monitors and the screens? Are they constantly throwing out all kinds of data and that's constantly changing by themselves?
No, not at all. Um, we do have a lot of software that we use. There's a scanner right now that's used for crime scenes. It's a 360-degree scanner, and we can use that to stitch together um, the pictures that this scanner takes, and so you can actually walk through it like a virtual crime scene. So that's pretty cool. That's been out there for quite some time, and it gets more refined every day. It's gone from something that, well, just like our video cameras, they went from this big, huge, bulky thing down to
The
our
cell phone,
iPhones.
yeah.
In fact, some people have said you can use your iPhone for doing this too, and I'm like, okay, I don't know if I want to do that. Um, so, you know, the data, the software that we're using, almost all of the disciplines within the crime laboratory use some form of software. In the DNA typing arena, we've got a lot of software out there, ranging from just taking the data that comes off the instrument that I described earlier with the CCD camera and all of the fluorescence. I can't see that with my naked eye. It has to go through software to spit out the answer for me. What I have to do is look at the data and make sure that it's right,
Hmm.
and make sure that everything looks as it should and makes sense.
What about the CSI effect? Ha- Does that like play a large influence in your industry, your field?
Absolutely. We talked a little bit about OJ being the turning point for funding. The other part, turning point for funding for crime labs, was a lot of the CSI effect, because people were expecting it. People were expecting the 3D virtual walkthrough crime scene. People were expecting DNA analysis to be conducted on every crime that there was. They were expecting some scientist to come in and talk about something. And so we got a lot of funding in California. There was some funding back in the early 2000s for cold cases, and there was, quite a bit of money that poured into that. And what we did was looked at cases in which there were no suspects to do the DNA typing on, and then we could put those cases into the DNA database to see if we could get a hit. So there was a lot of money from that one. And then the feds, with the Violence Against Women Act, um, put a lot of money into the biology DNA portion of forensic science, which some people say has its downfall because all of the rest of the disciplines kind of got forgotten. But in essence, it really did bring all of forensic science up, because people are expecting good quality work.
Hmm. So that really benefited the field then. I mean, just the entire public perception of how DNA works, even though it's false. But like you said, if they expect it,
Yes,
and then that's something that the law enforcement agencies just have to provide.
yes. I think it did help. I can remember the whole group of us at a professional meeting watched the first CSI show, and we were in this room watching it on TV, and we were just laughing because it was so funny to us. But to everybody else, it was probably very serious. We were pointing out all of the flaws. So, but it has helped.
So the character Scully in X-Files is said to encourage a lot of women to enter forensic crime solving. Is
Well,
there some truth to that?
when I first started in the field, I would say it's probably 30% female, 70% male. Right now, it's probably the opposite. Probably 70% female, 30% male. hmm
Wow, that's a big shift
It is a
change.
big, huge shift. Probably more so than any other field. Um, when, yeah,
Yeah.
when I first started, there wasn't a lot of
Yeah, I mean,
females.
we've even seen that in colleges, right?
Yes.
Now you have, I think it's 55 to 45 women versus men.
hmm
Yeah.
A lot more women are going into math and the sciences.
Yep. And then actually, you know what? Now that if you break it down, math and sciences, it might be larger than 55, 45. You might be closer to 65, 70% women.
Yeah.
Yeah. So if you were on a crime show, what would be your badass catchphrase?
I wrote it down. It's kind of schmarmy. Physical evidence is a silent witness, and the criminalist using science unlocks its secrets.
Do, do, do. That could be the intro to a TV show right there.
Oh,
You
that was
guys,
kind of fun to come up with. I tried to see. That was just going through my mind. What can I say? What can I say that doesn't really sound hokey? So this actually sums it up, really.
well, Jennifer, I want to thank you for coming on the show. We didn't get into the wine, but I do want to thank Lanny Clark with Prime London. He is our wine sponsor, and so good loan officer if you ever need a loan officer.
Okay.
Yeah. So thank you for being on the podcast.
Oh,
This
you're
is
welcome,
a
Mark.
ton of information. I'm gonna go back and Google a lot of this stuff because it just went right over my head.
Yeah.
But
And I'll provide you with some links so that if you want to put some links down for people to go in if they're interested in getting into the field,
yes, that'd
that'll
be
help.
perfect. Yeah, we'll go ahead and provide it on the YouTube description and Facebook links, and also the podcast. So
Cool.
yeah,
This has been fun.
yeah, it was a lot of fun. So thank you for being on the show.
You're welcome.
Thank you so much for listening to the podcast. Thank you to our producer, Sam Lubman. Please subscribe, like, comment, and share the podcast. Remember, you can listen to the podcast on iTunes, Podbean, iHeartRadio, Google Play, SoundCloud, and anywhere else you listen to podcasts. For more information on my business as a property manager and real estate team, go visit my website at marcguzman.com. I really want to thank all of you for listening. It means the world to me, and I hope today's episode provides you value in your day-to-day life. I created this podcast to help showcase the many great people that live in this world and help share some knowledge that I've learned along the way in life. Again, thank you for listening. Check out our sponsors, and I'll catch you on the next episode.